This is part 4 of chapter 9.1 lecture. So we have one last example here. This involves determining the sample size necessary for estimating a population proportion within a specified margin of error. So on the previous examples, what we did is we calculated margin of error. We calculate margin of error to determine a confidence interval. And sometimes in statistics and research, we want to limit our margin of error to a certain value. And if we know that margin of error, we then can determine what sample size we need that will allow us to have that level of margin of error. And so we just need to sample those many people. Their formulas look complicated, but it's pretty easy. So there'll be times you want to estimate the sample size required to create a confidence interval with a certain margin of error when you have an estimate for the p-hat. If you have an estimate for the p-hat, it's going to be p-hat times 1 minus p-hat. And then you multiply that by the critical value, C alpha over 2, divided by your margin of error in a decimal value. And then sometimes if you do not have an estimate for p, right? If you don't have an estimate for p, then your equation is actually just going to be 0.25 times z alpha over 2 e squared. And again, those formulas allow us to determine how many people we need to interview, sample, so that we can control our margin of error. And so let's assume an economist wants to know if the proportion of U.S. population who commutes to work via carpooling is on the rise. What sample size should be obtained if the economist wants to estimate within 2 percentage points of the true proportion with a 90% confidence? So that means alpha is 0.0. And what we're looking for is n. What sample size? Our E is 0.02. That's 2 percentage points. So, and then uses the estimate of 10%. So the economist thinks it has a value of 0.10. So how many people would he need to interview? Pretty easy. Since we have a prior estimate, we use this value here. And so it's a 90% confidence interval alpha. So then our Z alpha over 2 for a 90% is going to be 1.645. So we need all these values, 1.645. And then we can go ahead and just make the calculation now. So that's just going to be 0.10 times 0.90 times 1.645 all over 0.02 squared. That's it. That's how simple it's going to be. And then you would go ahead and do that calculation, and it's approximately 608.9. So we're going to round that up to 609 people need to be sample size, because you can't have 0.9 people. We got to round up to the next one. Now let's assume that the economist does not have a prior estimate, and the calculation then would be n is equal to 0.25, 1.645 over 0.02, my writing's getting bad, squared. And when we do that calculation, 1.691.3, round that up to 1692 people. Because we didn't have an estimate, we have to then now interview more people to limit our margin of error. And so that's what we would have, and that's what we would do here for these problems. You could also use StatCrunch in these cases. If we went to stat proportion, one sample right here, width and sample size. And so in this case here, what we're looking for is and that's problem is a 90% confidence interval. The target proportion, if we have an estimate for the first one, you could put 0.10 if you have an estimate. And then we want the width to be, the margin of error was 0.02, so the width is 0.04. That's the hard part of StatCrunch. Compute, and there's your 609, which matches up with what we got over here, 609. Now, if we didn't have a target population, I'd put just 50%, 0.50. Width is still 0.04. The margin of error is 2, so you have the minus and the plus, the two parts. So the total width of your confidence interval is 0.04. Sample size, and there's your 1691. And so you have those instructions to do that also somewhere. Let's see where it was. Down here on our notes. That's it for chapter 9.1.